Welcome everybody. In today's lecture we're going to cover some concepts related to the do-while loop, which is a loop that is similar to the while loop but has some key differences. And what are those differences? Well, the main difference in terms of execution of the while loop is that the condition of a while loop is generally checked after the loop body has been executed or has been performed. So with a do while loop, because the check follows the body or comes after the body of the loop, what that generally means is that your loop body will be executed at least one time. Now this is very different from a while loop or even a for loop, in the sense that the condition is checked first, and if the condition is true, only then do you enter the body of the loop. Whereas with the do while loop, you first go into the body, execute it, and then check the condition. And if the condition happens to be true, you go back into the body, and if it is not true, then you go to the statement that follows the do while loop. And so what that means is that your loop will be executed at least one time. Right. So what does the do while statement actually look like? Well, it basically consists of two keywords, a do and then a while. And yes, obviously that's why it's called the do while loop. The condition basically follows the while keyword. So this condition will be checked to ensure or will dictate whether your loop is going to be repeated or not. As far as the actual loop is concerned, this is what it looks like. So you first have the do keyword, then you have the body, and then you have the while statement. And one thing that is different is that you also have a semicolon at the end of the while statement, which you did not have in case of a simple while loop. Also, if you have more than one statement in the body, then you have to put them inside the curly braces, and that's something that you should also do. Now let's look at one simple program. Using the do while loop, we have an unsigned int counter. We put that inside a do, followed by curly braces, followed by a while statement or a while keyword, followed by the condition and the pre-increment inside a parentheses. Now what does this do? Well, it initiates the counter variable to 1, comes down here, and notice that this is a pre-increment. So if this statement was being executed before the body, then the first thing you would see here is 2, but instead you see 1, and that's because you first go inside the body, you print the value of counter, then you check, then you first increment the variable counter because this is pre-increment, and then you check, is that less than equal to 10? It's not. Go ahead, repeat it again, print 2, and that's how you keep going until you get to the end when you print 10, and then when it's incremented, the value 11 is where you exit the loop. Now that's the main difference between the while and do while loop, and that is your body of the loop comes first and your condition comes at the end. And then also remember that your condition will be followed by a semicolon. Let's look at the flow chart quickly. And what does the flow chart look like? Well, you have your actions or your body of your do while loop. So they come first. Then you go into the condition and check if the condition is true. You go back. If the condition is false, you come down. So what that means is the very first time that you hit a do while loop, you're going to execute the actions in the body at least one time. Then check the condition, and if the condition is false, then you will exit. So that's a key difference. Now the next concept that we're coming at is what is called break and continue statements. You could also think of these as break and skip statements, because the continue does something which is actually should be called a skip, but it's called continue. Now you've already seen the break keyword or the break statement inside a switch statement, and what that was doing was that it was basically taking you to the end of the switch statement. And so it serves a similar purpose in loops as well. And the break statement, whenever you put it inside a loop, so whenever it's inside a while or a for or a do while loop, you've already seen what it does inside a switch. What it does is that it causes you to immediately exit from the statement. So if you're inside a for loop and you see a break statement, what will happen is that your program will exit the for loop. It will exit the for loop which contains the break statement. Okay. So a common use is, you want to use the break statement to escape early from a loop or skip the remaining part of a switch statement. These are the two most common uses of the break statement. And we've already seen the break statement at work inside the switch statement. So not going to discuss the switch statement, going to talk about how it works inside a loop. So let's look at an example which is in figure 5. So what do we have? We have an unsigned integer x. We are looping or controlling a for loop using the variable x, starting from the value 1 and going up to 10. And then within that for loop, we have a break statement, and this break statement will be encountered, or your program will actually see this break statement if x is equal to 5, right? So what that means is when your program actually comes inside these curly braces, and it will only come inside it when x is equal to 5. When x is 5, you will see, your program will see a break statement, and then when it sees a break statement, it will stop the repetitions and it will come down here, it will come out of the loop. Okay, and then this is the next statement which follows the loop, so that's the one that will be executed. So let's see how it works. So you start from 1, you check if that's equal to 5. It's not. You go down here, you print 1, you go back up, you do the same for 2, 3, 4, and then when you get to 5, the statement becomes true. You go inside it, and then the program is telling you to come out, and that's what you do. So you just come out here, and then the statement is printed break or broke out of loop at 5. So the break statement, just like its literal meaning, brings you or breaks you out of the loop and brings you to the next statement that follows the body of the loop. Now, another statement which is related or similar to the break statement is called the continue statement. And what the continue statement does is that it makes you, so just like the break statement makes you skip uh, the rest of the steps or the remaining um, iterations of the loop, the continue statement only makes you skip a certain part of the statements in the loop. So, whenever a continue statement is executed inside a loop, what happens is that your program skips the remaining statements in the body of that loop, right? So if you have, let's say, a for loop and you have 1, 2, 3, 4, 5 statements inside the body, and let's say you put a continue statement here, what will happen is when your loop gets to line 3 and it sees a continue statement, and let's say the continue statement is put inside an if condition, so whenever this continue statement is true, what will happen is your loop will skip statements 4 and 5 and it will go back up and start from statement number 1, and then come to statement number 2, and then when it comes to statement number 3, if the condition that you're using to trigger the continue statement happens to be false, then it will go on and it will execute lines 4 and 5, and if it happens to be true, again it will skip lines 4 and 5 and go back up to line 1. So that's what the continue statement generally does. So let's look at an example. So this is very similar to the example that we saw on the previous slide. So again, we have an unsigned int x, which is starting from 1, going up to 10, being pre-incremented inside a for loop, and then if x is 5, so if you have this condition, so if x is 5, then you're going to continue, and if x is not 5, you're just going to keep operating as normal and keep repeating. So what that means is when this condition is satisfied, so once you actually get to line 11 and x is 5, you will go into continue, and when you go into continue, you're going to skip whatever comes after inside the loop, but instead of exiting the loop like the break statement, you go back up to the start of the loop. So that's how this is different from the break statement. Now in the break statement, if you put a break statement here like we did in the previous example, what would have happened is if x was 5, you would have exited the loop. But because this is continue, you just skip the rest of the loop, but instead of going out, you go back up. So let's see. You get these values 1, 2, 3, 4, and then notice there's no 5. You get 6, 7, 8, 9, and 10, and so your loop stops once x becomes 11. And then finally the statement says used continue statement to skip printing value, the value 5. Okay. Right. And then the next topic that we're going to discuss briefly is logical operators. And logical operators are basically operators that can be used to make more complex conditions um, than what we've been doing up till now, and they allow you to kind of combine simple conditions. So let's say you want to buy a car. Now, that's not a simple decision. There are multiple things that you consider when buying a car, or let's say buying a used car. So one question that you may ask yourself is, do I like this car? That's the first thing. That's maybe a yes or no question. So that's the first thing. So if this is yes, the second thing that you might say is it in good condition? You might say yes. And then, is it within my budget? Can I afford this? Right? And then another question that you may ask yourself is, um, maybe something like, does it have valid documents? Now, your decision is based on all these four factors. So it has to, and generally you would have to have like, do I like it? Yes. And is it in good condition? And is it in my budget? And does it have valid documentation? So these are all four conditions that need to be satisfied. And so in a condition like this, you may say like, okay, does it have like an and condition, right? But maybe you could add, so all of these conditions, so what we mean by an and is all of these conditions have to be satisfied. You could also maybe put one more condition. Let's say, is it uh, Toyota? And this could be an or condition. Or is it, I don't know, maybe a Honda? You can put whatever you like. Maybe you can put a Dodge here and a Chevy here if you like American cars. But this is an or decision. So let's say you also put this or condition in there. So even if I like the car, even if it is in my budget, even if it has valid documentation, if those things are satisfied, the other factor that I'm putting is it a Toyota or is it a Honda? Now, if one of these conditions is satisfied, then you can buy the car. Now, this would be or versus an and. So in this case, it's, is it a Toyota or is it a Honda? So that is also something. So what these statements basically allow you to do is to build more complex conditions to make decisions. Now let's look at the logical AND operator. What do we do with the logical AND operator? Here is an example. We have two conditions. So inside the if statement, and these both evaluate to either true or false. So the first one is gender is equal to 1. Let's say gender 1 basically could represent female. So if gender is 1, that means yes. So true is female. Then the second condition could be age is greater than equal to 65. Now, if both these conditions are true, gender is 1 and age is above or equal to 65, so both are true, only then will your if statement be true. So if both are true, so gender is 1 and age is greater than equal to 65, then the whole statement will evaluate to true. And if both these conditions are true, then you're going to increase the variable or increment the variable senior females. Senior is generally used to represent people who are above the age of 65, and in this case we are talking about women, so that's why we're saying senior females. So we're going to increase senior females by 1. Okay. And notice that you are using the logical AND operator here. So if gender is, let's say if the gender is not 1, so if it's a man, age is above 65, then senior females will not be incremented because one of the conditions in the AND operator is false. Okay, now so if any one of these conditions is false, so if either this is false or this is false or both are false, then the answer will also be false. Okay, let's look at the truth table of a logical AND. You might have seen this in your logical design course. So if the first expression is false and the second is false, the output is also false. If the first is 0, second is non-zero, so first is false, second is true, output is still 0. Similarly, for the first being false, true, and the second being false, a logical AND will only give you 1 at the output when all the expressions inside it are true. So in this case we have two expressions, so both have to be true or non-zero. Non-zero generally corresponds to true, then only then will it give you a true or a 1 at the output. Now another one is logical OR. The logical OR operator, what does that do? Well, you could think of this as maybe in this case you're thinking of assigning a student a grade of A. Now let's say there are two conditions based on which a student can be assigned or awarded an A grade. First one could be that the semester average, so marks on all quizzes and assignments, is greater than equal to 90. So if either semester average is greater than equal to 90, or now these double bars basically indicate an OR, logical OR operator. So either semester average is greater than equal to 90, or the final exam is greater than equal to 90. And so it is possible for a student to, for a good student to mess up on the final exam. So you can award a student an A grade even though he may have less than 90 on the final exam. But if his semester average is greater than equal to 90, then the student is awarded an A grade. And so with the logical OR operator, as long as any one of the two conditions is non-zero or is true, the output will be 1 or true. If both are false, then in that case the output will be false. Let's look at the truth table. So again, you get ones when either both or one of the conditions is true, and then you get 0 only when both expressions are false or 0. logical AND operator has higher precedence than the logical OR operator. So that's something that you want to remember, and then both associate from left to right, so they go in this direction. And it is possible that you can combine logical and logical OR operators to build much longer statements. You don't have to have just two expressions, and you can combine conditions with, let's say, or maybe, let's say you were only talking about Saudi citizens. Write this as this. So maybe have a binary variable which indicates is Saudi citizen, or, well, in that case, because if you're only talking about Saudi citizens, and this has to be maybe an AND condition. So you can combine this and then keep moving in that direction. But let's just say you also want to talk about women who have been residents of Saudi for more than 5 years. So you could put like, or resident more than 5 years. So maybe something like that. Sorry, I'm running out of space here. So you can put or and combine them together. So in that case, what will happen is this statement will be evaluated first, and if this condition is true, then you will move on to this second statement, because if this one is false, then there is no point evaluating this one on the right because you have an AND. So normally it is recommended when you have multiple checks inside being combined using an AND statement, you put the one that is most likely to occur first, because that is the first one that will be evaluated. So if you have three conditions, C1, C2 and C3, how it will work is it will go from left to right. It will evaluate the first one. If this is true, then it will evaluate the second one. If that is true, then it will evaluate the third one. So put this one here first. The one that is most likely to be observed should go first, because if this is false, then you will save a little bit of time and your program will not evaluate the condition 2 and condition 3, because you need all three to be satisfied. And so if the first one is 0, then there's no need to evaluate the ones that follow. And then finally we have the logical negation operator, and what that does is it basically allows the program to apply a condition which is the opposite of the condition that is inside a loop or something. And you have seen this already, at least it's also used for not kind of a thing. So in this case you have if grade is, so if the grade is sentinel value, what you say is if the grade is not sentinel value, so that's what it is kind of interpreted as, then the next grade is F or something. So the next grade is then printed, right? So if grade is sentinel value, so if the grade, let's say, I think the sentinel value we used was -1, so if the grade was -1, so if this is a sentinel value, what that means is this will be true, and what we have here is a not, so that converts it into false. and that's when you will actually, so if this is false, then you will not print the next grade, but that's how you will work. So logical or negation operator is also used, but often, so what it does is it does the opposite of what is inside the expression. So the expression is true, then this condition will not be executed, but if it is false, then you will consider that to be true and you will go inside the body. So you have 0 being converted to 1 and 1 being converted to 0, or true being converted to false. Now this does not sound very natural, so oftentimes it's just better to write this statement a bit more naturally. You can do it like that, but it's a little bit difficult to understand, so it's probably better to just write it the way that it is. So if grade is not equal to sentinel value, if the grade is not sentinel value, then the next grade is this. And this does exactly the same thing as what was being done in the previous thing, but that's is a little bit easier to understand and interpret because it's immediately read it from that. But in some cases, and this is kind of a bad example, in some cases not true makes more sense, and if you're in a situation like that, you have the option to use the logical negation operator. Okay, and then finally let's just look at the precedence of operators and associativity that's given on this table. So on this table you can see the precedence of the logical and the logical or. You can see that these are actually, the logical and has higher precedence than the logical or. Both go from associate from left to right, and yep, that's pretty much it. Finally, we have the Boolean data type, and just a quick word on that. Boolean data types are data types which can hold only values of 0 or 1. They're included in the standard bool.h header file, which defines bool as a shorthand type for Boolean. So this is a type of data, or a data type that you can use to work with Boolean values, true and false. And that's pretty much it. Finally, one more thing, and this is something that you hopefully know already. Do not confuse equality operators with the assignment operators. These are two very different things, and they can lead to serious problems in your program if you confuse the two. So always remember that if you want to compare something, or two variables or two conditions, then you have to use double equal to, which is the equality operator. So you're checking that their values are the same. But if you want to assign one value to another, then you have to use a single equal to. So this is more from assignment. So if you want to put some value, maybe the value of y inside x, then you can basically say something like x equal to y. But if you want to compare x and y, whether x and y have the same value, then you will have to use double equal to. So one example here is this: if pay code is double equal to 4, that means if your pay code contains a value of 4, then you get a bonus. But if pay code is equal to 4 with a single equal operator, with a single equal or an assignment operator, what that will do is it will assign pay code a value of 4, um, and that is a condition which, so when pay code has a value of 4, 4 is a non-zero value, so that is interpreted as true. So pay code is always going to be true, and what that will do is all your employees will always get a bonus. You will run out of money very soon. So remember this, two very different things between the assignment and the equality operator. So that's it. See you in the next lecture.